find the derivative denoted by g prime x of the function. In part A, we got a function given in terms of integral as a function of t and basically 1 through x. Now we know that from the fundamental theorem of calculus part 1, or first fundamental theorem of calculus, we know that when we have an integral like, let's say, some constant to x of some function, okay, it can be anything, a function, okay, and when we find its derivative with respect to x, this derivative and this integral, antiderivative, their actions cancel, and dt is together, by the way, and this function just picks up this variable, that's just the x, that variable, then times derivative of that, which is 1, and we just have fx. So using this, this is our ft, so we are asked to find the derivative, okay, and that is then g prime, that means derivative of this is number x, so it matches, and the ft, that simply, this simply becomes in terms of x, that's the up part, so square root of 3 x squared plus x to the 4th, and done. It just comes from this theorem, fundamental theorem of calculus part 1. Okay, let's move to part B. Okay, this is kind of part A, but these are not in correct position. We have to have x on the top variable and number on the bottom, a lower limit. So we can rewrite this function as, so let me rewrite, I'm gonna write 2 and swap the limits for, I have to pay -1. When we swap, then there is -1, and this junk 5 minus sine t over cosine t plus 2t. Now without negative sign, this matches with our theorem. So now I'm going to take the derivative of this integral, and that integral is denoted by g, so g prime is, this negative is there, like in this formula, this is our ft, and this simply picks up the variable x, so this becomes 5 minus sine x all over cosine x plus 2x final. Now part C, number and, this is a function of x, okay, slightly different. So in that case, we need to multiply the final answer by derivative of this, because we can say this is u, and this becomes, the whole thing becomes, when we have a function of u and when we find its derivative from the chain rule, this with respect to x times u prime, so we multiply by u prime. All that means just multiply by derivative of 2x, which is 2. So the derivative in this case, like earlier, all we have to do is replace t by this upper limit, the variable, so that is 2 minus 5 times 2x, 10x, plus 7 times 2x squared. What is that? 2 squared is 4, 7 times 4, 28 x squared. Not done. Times, okay, we did not multiply by anything, that is, in fact, we multiplied by 1. We used to have x on the top, and derivative of x was 1, but in this case derivative of 2x is 2, and that comes from the chain rule. Okay, so the last question here is is part D. Again, a number on the top, function on the bottom, so we need to rewrite this. Okay, this is same as I'm going to write 0 on the lower limit ex 5 cosine cube t dt. When I swap, then I have to multiply with negative. Now we can take the derivative of this function. Derivative is like in previous steps, all we have to do is, this function picks up the variable whatever on the top. So 5 or negative is there in the front. 5 cosine cube of this ex from the chain rule times, now find derivative of ex, which is ex itself. Final